on piecewise functions like these, we want to evaluate the limit based on where our x value in the limit is in terms of the piecewise function. So this function is defined as x squared plus 1 for values of x less than 0. So if we were evaluating the limit for anything less than 0, we would simply substitute into that top part of the piecewise function. Then when x is greater than 0, this function is defined as 2x plus 1. So for any value of x greater than 0, then we would evaluate at 2x plus 1. But the problem here is we want to know the limit as x approaches 0. And from the left and from the right of 0, we have different functions. To do a problem like this, we are going to evaluate these functions one-sided. So let's do the right side. So here, when x is greater than 0, or a little bit to the right, the function is 2x plus 1, and we can substitute 0 in there and get a value of 1. Then we evaluate the left side. X approaches 0 from the left. Those would be values below 0, and that would be x squared plus 1. When you substitute in 0, you also get 1. So here, this function from the right and from the left, it's approaching 1. Even though this function is not actually defined at 0, because the limit from the right and the limit from the left are both 1, the limit as x approaches 0 of this function f of x is simply 1.